Okay, so I'm making this video as kind of a backup in case we didn't quite finish the 4.3 notes in class on Tuesday. So I suspect we're probably going to get to about right here, top of page 5. So I'm going to start right here with this converting between logs and exponents. If we got further than that in class, then you can kind of fast forward this video to wherever we left off. But hopefully that will kind of get you going. Okay, so remember we talked about in class that logs and exponents are inverses of each other. They're different ways of saying the exact same thing, okay? So remember the whole, if we had an exponent right here, this is an exponential form. If we wanted to convert it to a log, we would say log base 2. So the base of the exponent is the base of the log. I say that over and over. The base of the exponent is the base of the log. The whole point of a log is to get the exponent by itself. So if 3 is the exponent when we're in exponential form, then 3 must be what's by itself in log form. And then that must mean that 8 comes right over here. So 2 to the third equals 8. That's true. 3 little 2's multiplied together makes 8. 2 to the third is 8. But in log form, we would say log base 2 of 8 equals 3. Okay, so log base 2 of 8 equals 3. Or if you're in log form already, remember the base of the exponent's the base of the log. So the 2 becomes your base. The 3 would be the exponent because the whole point of a log was to get the exponent by itself. So 3 must have been the exponent. And then 8 would be the part that's over here by itself. We call this part right here, not the base of the log, but the part that's next to it, we call that the argument. The argument is the vocabulary word for that. We're going to reference that term argument over and over. So we want to get comfortable with that. Okay, so here's a few questions. They just want us to convert back and forth. If they've given us logs, they want us to practice converting to exponents. If they've given us exponents, they want us to practice converting that to logs, okay? And the numbers always work out, so it's kind of a built-in check for yourself. But make sure that you're not just converting in a way to make a true statement, but you're converting in a way that, yes, that follows the rules of logs, okay? So remember, the base of the exponent is the base of the log. So if 4 is the base of my log, then 4 is going to be the base of my exponent. The whole point of logs was to get the exponent by itself. So this 2 that's over here by itself in log form must have been the exponent in exponential, and that means 16, our argument, must be the part that's over here by itself. And sure enough, 4 squared is 16, so we're confident that log base 4 of 16 does in fact equal 2. So we've taken log form and converted to exponential. Okay? Same idea here. We've got log form, we want to convert to exponential. So the base raised to the exponent equals the argument. Okay? If you wanted to check, remember we talked about the other day that a negative exponent really means keep it as 5 to the 1 but put it on the bottom. And sure enough, the fraction 1/5 is the decimal 0.2. So that does check. It works. Okay? All right. Here, log base 8 of 1 equals 0. So the base of our log is the base of our exponent. Raised to this exponent over here equals our argument. And sure enough, 8 to the 0 is 1. Remember, anything raised to the 0 is 1. Actually, any non-zero number raised to the 0 is 1. Okay? So that checks out. Same idea here. This is a log. We're converting to an exponent. So 23 to the 0 equals 1. Now, I want you to notice something here. Anytime you see an argument of 1, that's actually a really fast problem to work. This is going to happen quite a bit. Anytime you see the argument is 1, you know that that whole log expression will equal 0. Okay, 0 was the exponent because 8 to the 0 is 1, 23 to the 0 is 1. So when you see that 1 in the argument position, you knew it had to equal 0. That's going to come into play a little bit later. That's going to be really important. Okay. By the way, if you want to type a log in your calculator, if you are using one of the newer 84 calculators, this will work. If you are using an old TI-83, we'll see a shortcut in 4.4 that will help you type in your calculator. But most of you are using the newer 84s. If you hit the math button, okay, and then you scroll down in that math menu to option A, so go 0 through 9, 1 through 9, then 0, and then option A. Option A says log base. And when you type log base, then you can fill in whatever number you want in the base position, and then arrow over and type in whatever you want in the argument position, and it will work it out for you. Okay, so that's a way, a little bit later that you could check that. Notice that on a test, I might not give you numbers that you recognize. It might say log base P of J equals N. So could you convert that log equation into an exponential? Sure you could. The base of the exponent is the base of the log. The whole point of a log is to get the exponent by itself, so N must have been the exponent, and the argument is the part that would be by itself. So on a test, it might not be one you could type in a calculator to check. You might have to just know where the parts go. And I think there's a couple of homework questions like that. Same idea here. They've given us exponentials. I know they're exponentials because they've got an exponent, okay? And we are converting to logs. So the base of the exponent is the base of the log, so log base 2 of, now we got to decide which number goes in the argument position. It's going to be the 16, because remember the whole point of logs is to get the exponent by itself. Okay? Again, you could type this in a calculator, make sure it's true, that one in the calculator, make sure it's true. We know these are just different ways of saying the same thing. Okay, here, log base 27 of 3 equals 1/3. And the last one, log base 1/4 of 16 equals -2. And again, you could practice typing these logs in a calculator and making sure that it made true statements. Okay? All right. Remember, the argument always has to be a positive number, so these have always worked out where we had positive numbers in our argument position. Okay. Next page, they ask us to evaluate. Evaluate is a fancy math way of saying work it out. It doesn't exactly mean solve. We solve equations. X plus 3 equals 5. You solve the equation and find that x equals 2. Evaluate would be something like 3 plus 5. If I asked you to evaluate that, you would say, oh, that's 8. You're not solving an equation. You're just evaluating it, figuring out what number it's equal to. All right, so when they ask us to evaluate log base 12 of 144, they want to know what number is that equal to. Okay, what number does log base 12 of 44 work out to be? Okay, so I'm going to put a little blank right here, and I'm going to think about this for a second. I know that if I take this log and write it as an exponential, I'll have 12 to the something has to equal 144. Well, what should go in this spot right here? 12 to the something has to be 144. Oh, 12 squared is 144, so I bet log base 2 of 144 is 2. Okay, now you could type that in your calculator. You can say math, log base 2 of 144, oops, sorry, log base 12, isn't it? Log base 12 of 144, and it'll tell you, oh, that's 2, okay? But remember, on a test or something, it might not be a number that you're as familiar with. It could be, just converting, okay? All right, I guess on a test, it probably have to be numbers that you knew, but just wanted to get you comfortable with, make sure you're not relying too much on the calculator, that you understand the process, okay? All right, so in this case, 64 to the something has to be 8. And this one's kind of weird because our number's getting smaller, isn't it? Well, I know the square root of 64 is 8. And is there an exponent that would mean the same thing as square root? There sure is. Remember, raising something to the 1/2 is the same thing as taking the square root. So that's going to be 1/2. If you type that one in your calculator, log base 64 of 8, and it'll say 0.5. We know that's 1/2. Okay? All right. This one, 3 to the something, has to equal 1 over 27. Well, good grief. What's going to happen there? Well, I know that 3 to the second is 9, and I know 3 to the third is 27, so I think there might be something with the 3. But remember, if we wanted to, 3 to the third is 27, but if we want to send it down to the bottom, we would need to make it a negative. So I bet you that log base 3 of 1 over 27 is -3. Okay, and sure enough, you could type that in a calculator and it would say -3. Okay? All right, common and natural logarithms. Base 10 comes up so often. We use log base 10 so often that we said, you know what? let's just make it a shortcut. Anytime we want the base to be 10, let's just write regular old log. So if they write log without a base on it, they're telling you the base is 10. So from here on out, we'll never write 10 as a base. We'll just know that if the base is 10, we won't write anything, okay? Another log that comes up often is log base e, okay? In fact, log base e comes up so often that a shortcut is to just call it ln of e. I'm sorry, ln of x. So ln means log base e, but it's a shortcut. Instead of writing log base e, you just write ln, and people know, oh, that's log base e. It's a shortcut to save you so much writing. On your calculator, you probably noticed there's a button that says log. So if I just type, log, well, this first one here, log 100, I know that that is 2. Now, where does that come from? Well, remember, the base here is 10. They didn't put 10, but we know it's 10. So 10 to the something has to equal our argument of 100. Oh, 10 squared is 100. So that's why log base 100 is 2. But because the base there was, I'm sorry, not log base 100, just log 100 is 2. The base was 10. So instead of having to go to math, arrow down to log base, and then type in 10 and tell it that the argument's 100, it's a lot faster to just hit the log button and say 100. They mean the same thing, okay? All right, what about this one? Well, base here is 10. 10 to the something has to equal 0.0001. Well, good grief. What number is that? Well, the 1 is in there's the tenths place, the hundreds place, the thousands place, the 10,000ths. So hopefully you agree that this number right here is 1 over 10,000, okay? Well, 1 over 10,000, oh look, my 10 went to the denominator, so I know that exponent's negative. And then I just got to think, how many times do I have to multiply 10 together to get 10,000? Well, 10 times 10 is 100. Times another 10 would be 1,000. Times another 10 would be 10,000. So I must have 4 little 10s being multiplied together. So 10 to the 4th is 10,000. And if I want to stick it on the bottom, I would need a negative in that exponent. So log of 0.0001 is negative 4. And again, you could type that in a calculator. And it'll tell you negative 4. Sorry, you can see that better. Okay? All right. Next couple here. These are LNs. Remember, ln is a log, but the base is e. So get this. This is kind of weird. This is really saying log base e. Now, it's not this e. There's a little base right here. They're basically saying this. Log base e of e to the negative 3. Only they didn't write log base e. They just put ln in that place. Okay? All right. Well, if I think about it from rewriting as an exponential, this base right here, this base of the exponent's the base of the log, so e to the something has to equal the argument, and my argument is e to the negative 3. So what would go in that spot? Oh, it must be a negative 3. Okay? Now, in your calculator, here's kind of a cool trick. What we're going to learn in 4.4 is that anytime you have an exponent, there's a property that says, hey, you could just pull that property down front. And so that it would be negative 3 times ln e. And ln e in your calculator, if you just type ln e, I have to tell my exponent there on the e is 1, it's going to say 1. So if I say ln of e to the negative 3, it's going to tell us that that's negative 3. Okay? Same idea here. Even though they don't write the base, we know the base is e. So e to the whatever this is equals our argument, our e to the 10th. So what has to go in this blank? 10. Again, you could type every one of these in your calculator and verify, but as we move forward, we want to start being able to kind of think them through on our own, okay? Okay. Well, so far, they've always worked out. We knew that 12 squared was 144. We knew that the 64 to the 1/2 was 8. We were able to work those out kind of in our heads. Sometimes the numbers are messy. For instance, this one right here, we know the base is 10. 10 to the something has to equal 200. And I'm pretty sure that there is not a whole number that I can raise 10 to in order to get 200. I know that 10 to the 1 is 10. I know that 10 squared is 100. I know 10 to the 3rd is 1,000. But I'm never going to get a 200 to come out if I'm putting whole number exponents in there. But hopefully you would agree that there is a number between 1 and 2. 10 to the 1 is 10. 10 to the second is 100. 10 to the third is 1,000. I'm sorry, not between 1 and 2. There's a number between 2 and 3 that would give you 200. 2 point something or other. So in your calculator, we know the base is 10, so I can just hit the regular log button. I don't have to do the log base. I can tell the calculator log 200, and it's going to go, oh, that's 2.3 something. Okay? And I'm not surprised that it's 2 point something because 10 squared was 100, 10 to the third was 1,000. 1,000 would be too much. So I knew it had to be 2 point something, and my calculator gave me that value. Okay? As a check, I could say 10 raised to the whatever number I just got. I'm going to arrow up in my calculator and grab it. I'm going to say, hey, 10 to that number, and it comes out basically to 200 if you could kind of, rounded it. So I know that that number, my log of 200, is going to be 2 point whatever that was. They told us to round to 4 decimal places, so I'm going to say 2.3010, because that zero right there is in the 4th spot. Okay? All right. Log 0.074. Again, I can just type that in my calculator. Negative 1.130, and I'm going to have to round that 4th decimal to 8. Okay? And so on. Notice this log 200 and ln 200 are not the same. For the ln, that's log base E. There's a log button and an ln button. Okay, when you hit ln, it's assuming you're doing log base E. So log base E of 200 is 5.2983. And again, what's happening behind the scenes is the calculator's going, oh, E to the something has to be 200. And the calculator's working it out what that decimal would need to be. Okay? 18, same idea, tap in your calculator, and you get 0.0050 when you round to the 4th decimal there. ln 1.005. Yes, 0.0050. There we go. Okay? All right. A few little properties of logarithms here that we need to kind of be aware of. We've kind of talked about these a little bit already, but I want to kind of show them to you more. Notice that when the argument is 1, that whole log is equal to 0. And the reason why, if we converted it to exponential, we'd have b to the 0 equals 1. Well, yeah, anything to the 0 is 1. So from here on out, anytime we see a 1 in the argument position, we know that whole thing is going to equal 0. So for instance, right here on number 22, see how it says log base 273 or 1? People panic when they see that 273. It doesn't matter. That whole thing is 0. Because 273 to the something has to equal 1. There'll have to be a 0 in that spot. So anytime I see that the argument is 1, I know that whole thing is 0. So this one's 0. Do I see any other places where the argument is 1? No, I think that's the only one. Okay? All right, next one. Log base b of b equals 1. Now here's why that's the case. If we converted that to an exponential, the base of this log would be right here, the b. Exponent would be a 1, and then our argument of b is over here. Well, sure it is. B to the 1, of course is b. Just like 5 to the 1 is 5, 18 to the 1 is 18. Of course it is. So anytime your base and argument are the same thing, you know that log expression equals 1. Okay? So on number 19 here, yeah. Log base 19 of 19. I know that's going to be a 1 because my base and my argument are the same thing. If I were to convert it, 19 to the 1, of course, equals 19. So it would have to be a 1 right there. Okay? Now, here's where that gets a little tricky. Log 10. They didn't write a base, but we know it's 10. So here's another case where the base and the argument are the same thing. So the whole thing's equals 1. And 21, ln of e. Again, if you were to convert it, they don't write that the base is e, but we know it is. So e to the something has to equal e. Well, yeah, that's going to be a 1. Our base and our argument were the same thing. Okay? So from here on out, anytime we see a log 10, we know that's a 1. Anytime we see an ln e, we know that's a 1. So that little trick I showed you over here, okay? This is basically, we're going to learn later, if you have an exponent, you can pull it out front. So that negative 3 could come out front. and then you have ln of e. Well, ln of e is just 1, so 1 times negative 3 is negative 3. Here, this is an ln of e, log base e of e raised to the 10th. So yeah, when you pull that 10 out front and you have ln of e is 1, and that's going to leave just the 10. So it's a different way of thinking about that same problem. Okay? All right. Next example here, we have a log. Okay? Notice there's an exponential in the argument position. So this is a log expression, but there's an exponential in the argument place. If I were to convert this whole thing out of log form and into exponential, this is my base. So there's my b. Raised to the exponent, raised to this x, has to equal the argument of b to the x. Well, yeah, that has to be true. So b to the x, of course, equals b to the x. So notice what happens. If you have a log where the base and the argument are the same thing, that essentially cancels out. It made a 1, right? We saw that a while ago. Log base b of b was 1. But whatever that exponent is will still be there. So that's why the log base b of b basically just canceled and left just the x, whatever that exponent was. Another way to think about it, if I had log base 4 of 4 squared, okay, that's going to equal 2. Because if I pull that 2 down front, I'd have 2 times log base 4 of 4. Anytime the base and the exponent are the same, that's 1. So 1 times 2 is 2. Okay. This one, I know you see the word log, but this is really an exponential. Okay, because we have an exponent. That log is in the exponent position. So if we converted this to a log expression, here's our base. So log base b of x, x would be in our argument position, equals the exponent log base b of x. So that came there. So if we have an exponential where the log is in the exponent position, and that base and this base are the same, it's going to cancel and leave us with just whatever our exponent, our argument right there in that exponent was. Okay? All right, so let's practice some of those. Notice, here's a case. 30 is the base of the log, 30 is the base of the exponent. Those basically just cancel and leave us with 10. They didn't write the e as the base, but we know it's there. ln of e is 1, so that's going to leave us just the negative 12. Okay, log, the base was e, the argument was e, so that's going to leave us with just that negative 12. Okay, here's one. This is an exponential. The log is in the exponent position. Notice the base on that little log right there is 10, which is the same as this base here. Those cancel and leave us just the 14. Here's another one. This base and the log are the same, so that's going to cancel and leave us with just the 5. Okay? Okay, next little group here. They just ask us to convert. So if you'll notice, some of these are exponentials, so we're going to convert them to logs. Some of them are logs, so we're going to convert them to exponentials. So just convert the other way around. Okay? Here's a log, so we're going to convert to exponential. 5 to the second is 25. This one's an exponential, so we'll convert to log. Log base 3 of 1 over 81 equals negative 4. Just making those conversions. Here's an exponential. So log base 10, but keep in mind, do we have to write the 10? No, we don't write the 10 if it's a base. So log implied base 10 of 1,000 equals 3. Okay. Here's another one. It's a log, so to convert to an exponential, we'll have 2 to the 4th equals x. Now at this point, we're just practicing the conversion, but what we're going to see in 4.5 is what if we have equations, log equations or exponential equations that have x's. So we probably don't know what this x variable is worth. But if we convert it from log form to exponential, I bet 2 to the 4th is something we could work out. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So this x was worth 16. So what we're going to see in 4.5 is if you have an equation with a log in it, you could convert to an exponential and probably solve and figure out what x is worth. In this part, we're not having to solve. We're just doing the conversions. Okay? So log, on this one, log base 5 of 25 equals x. Okay, so sometimes you might be given an exponential equation. And of course we know in this case that x has to be 2 because 5 squared is 25. But if it's numbers you didn't know, maybe 5 to the x equals 812. Well, that's probably not a whole number. So what you could do is convert to a log, and then you could type the log base 5 of 812 or whatever it was into your calculator to figure out what x is. And that's exactly what we're going to do in 4.5. But right now they just want us to practice the conversion. Okay, here's a log. So to make it an exponential, 7 to the x is 49. I bet you could figure out that x had to be 2. Or inverse, log base 49 of 7 equals x. Okay, and if you needed to solve for x, you could type this in your calculator and you could probably figure out what x is. It's going to be 1/2, right? The square root of 49 is 7. All right, here's one with an e to the x. This is an exponential. So log base e, but we don't write log base e. Instead, we put ln. ln means log base e. So log base e, or ln, of 8 equals x. So if you needed to solve this equation for x, you probably don't know what the original is in your head, but could you type ln 8 in your calculator and figure out what x is? Same idea here. We've got a log, so to convert to exponential, x to the second equals 9. And then if they asked us to solve it, could we take the square root and keep going and figure out what x is? Yeah. And the last one, this is an exponential. So log base 5, remember the base of the exponent's the base of the log, of 1/5 equals x. Okay. More, we're just kind of working these out, thinking them through. Okay, evaluate means work it out, see what number it is. Okay, so you could type that in a calculator, certainly, but you could probably also kind of think it through. Base here is 10. 10 to the something is 10,000. Oh, I bet that one's going to be a 4. Okay. Remember, implied base 10 here. If your base and your argument are the same, that whole thing is going to be a 1. Okay. Implied base 10. 10 to the something equals 1/10. Oh, I bet that's going to be a -1. All right. So again, all of these you could type in a calculator, no problem. Let's skip this one for just a second. Let's look at this row. Implied base 10, 10 to the something is 100. Oh, that's going to be 2. 10 to the something is going to be 1. Ooh, what would my exponent need to be so that I get a 1 in the argument? We talked about that a while ago. Remember, if the argument is 1, we know the whole thing is 0, right? This one, 10 to the something, has to be 1/100. Well, I know 10 squared would give me 100. If I want that to go on the bottom, I bet I have to make it negative. Okay, and again, you could type these in your calculator to confirm, but hopefully you're getting better at some of those properties, okay? All right, as we talked about at the very beginning, our arguments have to be positive numbers, okay? So if you were to type log 0 in your calculator, it's going to give you an error message. Okay. Same thing if you type log -1. Okay. If you type log -1 in your calculator, it's going to give you an error message. It says non-real answer. You're getting into imaginary numbers. Okay. And the reason is, if you were to try to convert that, base is 10. 10 to the something equals 0. Is there anything I can raise this to that would equal 0? No, because if I make 10 to the 0, 10 to the 0 is 1, not 0. If I put a negative exponent, that just sends the 10 on the bottom. So there's no exponent I can use here so that 10 to that exponent will give me 0. Okay? There's nothing that will work. Okay? So this is, you're going to get an error message in your calculator. Okay? So we're going to say, hey, not solvable. We can't work this. Okay? Argument must be positive. Okay? We cannot have a 0 in the argument position. So this is not one that will work out. Same thing here. If I took 10 to the something and needed it to equal -1, there's no way that can happen. If I put a 10 to the 0, I would get +1, not negative. If I put 10 to the negative number, I would get 10 to the whatever on the bottom of a fraction. That wouldn't make it negative. So there's not a way that I can work this out to get a -1 for the argument. So that's not possible. These are both error messages because the argument must be positive. Okay? Keep that in mind. It's going to come up a lot. Okay, this next group, they want us to evaluate. That means work it out. A lot of these you're going to know in your head. I encourage you to do that. If you need to work it out with your calculator, that's fine. Think your way through here, okay? So this is saying 6 to the something equals 36. Oh, I bet it's squared. And again, you could type that in your calculator, but try to think it through. Okay, 3 to the something equals 1/3. Oh, I bet that's a -1. The -1 exponent would send that 3 to the bottom. Okay? 3 to the something equals 27. Oh, 3 times 3 is 9. 9 times 3 is 27, so that's going to be a 3. 2 to the something equals 1/4. Well, 2 squared is 4, but I want the 4 on the bottom, so I'm going to have to make that a -2. 2 to the something equals 16. Those are powers of 2. 2 to the 4th would make 16. 4 to the something equals 2. Ooh, how can I go from 4 to 2? Well, I could take the square root of it, right? Square root of 4 is 2, so I bet that's the exponent 1/2. So log base 4 of 2 would equal 1/2. Okay. Here's one where the argument and the base are the same thing. Remember, those are always 1 if you needed to convert. 3 to the 1 would equal 3. Here's one where the argument is 1. Anytime the argument is 1, we know that equals 0, because 7 to the 0 would equal 1. Here's one where the base and the argument are the same thing. Basically, the result is that coefficient, or that exponent drops down in front, so 2. Base and argument are the same thing. Argument's 1, that whole thing is 0. And here's a log where the argument and the base are the same thing, so that 3 drops out front. And the log 5 of 5 is just a 1. Last couple of these. Base and argument are the same thing. Argument is 1. Base and argument are the same thing. That's going to leave just that 1/2 exponent. Okay? And then these last few are ones that you would just type in your calculator. You could try them on your own, but 10 to the something equals 30,000. That's probably not going to be a whole number. It's not going to be one that we can do in our head. So you're just going to type in log 3,000 in your calculator. Okay? I believe it comes out to be 4.477. This one, 0.477. Notice I said 3 decimals here. Ooh, here's one we recognize. Remember, what happens when that argument is 1? We know the whole thing is 0. Okay? Ooh, what happens when the argument is 0? Does that work out? No. That's an error because the argument must be positive. Okay, so that's how you get that error message if you typed it in. Similar ideas here, except it's natural log. It's ln instead of log. So you're typing that in a calculator. This one, it came out negative 1.204. Ooh, remember, they didn't write the e, but we know this is log base e. So the e in the argument and the e in the base cancel and leave us with just the 5. And this would be another error message because our argument is a negative number. Remember, your argument must be positive. All right, so that's the end of 4.3.